you? What are you? Don't just be laying around. There are so many opportunities for us in the air to catch in every aspect. So I pray that this new regime will favor every one of us and make us to think ahead of the world.
Okay.
The youth shall grow. The youth are already growing. God bless you all.
Thank you, madam, for that word of encouragement. Always have the youth at hand. The youth are growing and we're also growing. Some people do not believe that the youth are actually growing in this country. We hope that we are actually going to grow.
You have grown up. We have grown up.
Okay, without wasting much of our time, because today is a very tight for almost every one of us. So we'll try to go straight to the business of the day as much as we can. Today we'll be bringing to you somebody who also will be discussing with us on this important topic when it comes to these parameters of lithium processing lines. We'll be looking at different parameters because we found out that a lot of people put in a line without even understanding the processes and some of the things to actually take on. And at the end of the day, after the plant has been installed, we found out that the next thing will be that some lines are not in place. You know, like I visited one plant last 2 weeks. In short, for them to come up again with the necessary things line that are not there, it will be like working 50% on what they've actually done before. And that is actually disastrous. But these are just simple systems that would have actually put in place prior to installation of those plants. So some of these evaluations are now actually done and they lack along the line. So installing some of these things and making decisions are not just one thing. You need some metallurgists, you need a lot of people to bring in everything on board, because if your design do not actually marry well with your ore or your production and all that, you start having issues along the way. So it's not that because Mr. A has a plant in Shagam and you also want to put your plant in Shagam, what is the composition of Mr. A mineralogy? What is the composition of environment? What is the production like? What is, so many things are actually involved if we actually want to talk about that, you know. But today we'll also only be dealing with the parameters that actually involve, you know, in testing before you start a beneficiating plant or you start a process and all that. So today we'll be inviting Christopher on the platform. Christopher Yume Ebong is a general manager. He's somebody who has actually put a lot of experiences in metal mining chemistry, with a lot of projects is actually handled when it comes to processing plants, water treatment plants, ammonia plants, urea plants. He's also skilled in mineral method development and also sampling pre-treatment and wet chemistry of various mineral ores, you know, including the lithium ore, spodumene, the amblygonite, the lepidolite, the petalite, and all other stratified kind of deposit, also bauxite and limestones. So Christopher is well experienced in ammonia and urea analysis, calibrations, and also troubleshooting of all analytical instrumentation. Also skilled in soil, water, heavy metal analysis, quantitative and analytical technical skills, coupled with a team spirit attitude. I've actually worked with Christopher on different projects, and I've seen he's somebody that one can actually depend on when it comes to something of this nature. So please, ladies and gentlemen, let's make welcome of Christopher Yume to the platform. Christopher, the platform is yours. You can unmute yourself. You can project from your end, right?
He can project for me.
Okay. Let me see. Okay, screen. Okay. Is that on now?
Yes, perfect.
Okay, you can go on.
All right. Good afternoon to everyone. I'm happy to be here once again. I think this is my second time presenting in this forum, and I don't take the opportunity for granted, especially when it comes to sharing of professional knowledge. Thank you for the organizers of this event, Mr. Gideon personally as my friend, and worked with him for a number of projects, and also for the coordinator. I think this is my second time meeting the coordinator. Thank you for this opportunity. And then just this forum is very important for us as the mining professionals, as geologists, and as chemists, and those that want to see Nigerian mineral sector moving to the next level. So we need a lot of these almost all the time, so that we can just be at the forefront of what is happening in the society. I don't know if everybody can hear me. I hope my audio is good. Oh, okay. All right. So today we'll be looking at shortly so that we don't waste much of time. And happy inauguration, by the way. Today is a very tight schedule for everyone. I have to just run down just because of this, if not because of Gideon. He knows the kind of project I'm handling right away, so my schedule is very tight. But I just have to, make myself available for this, for us. So thank you very much. So we're looking at parameters of mineral testing required for development of lithium processing lines. And I know a lot of people will say, I'm not an investor. I don't want to build a lithium refining plant, or I don't want to build a mineral refining plant. So why are we having this topic? The way Nigeria is going, I'm promising you, once we get the right people into power, the mineral sector is a sector that can, on its own, be able to take care of the Nigerian economy. I'm telling the gospel truth. We have all the resources it takes, both from critical metals, industrial deposit, base metals, whatever, all the metals you can think of, all the mineral ores you can think of, we have it in Nigeria. And they are not just in mined quantities, they are available in commercial quantities that can be mined and that can actually boost the economy of this country. So you don't need to take any information for granted, because we already know what's happening in the lithium industry now. It's a far-fetched industry that almost everybody is trying to get something out of it. Even the old man, the old women, the children. If you go to some mining site, you see some children there on the mining site, trying to gather some lithium ores. So it's a very good project and a very good prospect for all of us. But having said that, before you can set up any lithium processing plant, it's the same to every other processing plant at all that you may think of. There are some parameters you have to control. There are some parameters you have to test. So I'll be running you through all these parameters. They are much, but I'm just going to be making it an overview so that we can get all the information that we might likely have to get anyways. I know what some of us here are geologists, some are chemical engineers, and I think some are lecturers here. I think I saw a professor here, and I think some are also chemists too. So I will try to simplify the context so that everybody can be carried along. Because when we're talking about parameters like this, we have to talk about things like chemical engineering. We have to talk about process flow, process control. We have to talk about surface chemistry and a lot of them. And some of us might not be familiar with those terminologies. So the slide is made in such a way that everybody can just, get the information. So I think we can just proceed. Thank you. Thank you. So looking at the introduction, looking at pilot plant testing, we're looking at parameters for testing and test work, we're looking at different types of gravity tests available, and then test procedure. Please, next slide. Okay, so already we are all aware of the lithium rush in the world, not only in Nigeria. It's also happening in the world, in Africa, in every part of the world. Everybody's looking for lithium minerals, and the reason is simple: because of the use of lithium in different purposes, especially in the lithium-ion technology, lithium-ion battery technology, and also as the energy storage system. So everybody's looking for this metal to mine, or some people looking for mining sites to buy. Like currently in Nigeria, you can see a lot of Chinese coming in on daily basis just to, to take either to buy it on mining site or to actually take up to exploit the minerals, as the case may be. So it's a very fast growing technology. It's a very fast industry. Lithium industry is a very fast industry in the world as of today. And lithium alone is not just the only energy storage system. We classify it as ESS, energy storage system. It's not the only energy storage system. There are other energy storage systems that that are also in place. Like currently, there is a new research on sodium-ion battery. Yeah, there's also a new research on sodium-ion battery. The only difference in sodium-ion battery is that it does not have the capacity to store the energy for a long time. So everybody still falls back to to lithium. But that does not withstand with the advent of science and with as the research is going on. I believe that they will to have a breakthrough too for for sodium metals. So all those sodium compounds, or when you do analysis and you see that there is a high levels of sodium in your sample, please don't throw it away. Very soon, the same way we are rushing for lithium, we're also going to be rushing for sodium as well. So just keep them aside. We're going to be working on that. And also, I think a friend of mine a few weeks ago also told me that the lithium itself, they are working on the research where they are going to have electrically charged aeroplanes. Okay, no longer be using a fuel jet. The jet itself or the aeroplane will be having batteries that will just just fly off. So the lithium industry is very, very growing, and we already know the different types of the lithium ores, like the spodumene, the lepidolite and amblygonite, as the case may be. The spodumene, which all of us know as the chlorite, the local man call it the chlorite. The lepidolite, which they also locally refer to as morgan, and the amblygonite, which is the lithium phosphate, which they also locally refer to as as amblygonite. All these metals or all these lithium ores can be processed. Now, the purpose of processing is for us to concentrate these metals so that we can have them in high quality, and at the same time, there should be low impurities as present. So there are different methods, different processes that are used for for the processing of these metals, for the beneficiation of this lithium. So we are going to be looking at them and why paying attention to the parameters that we need to test while setting up a lithium refining plant. And also, before we proceed, I have to pinpoint to what we call a pilot plant. Please, next slide. A pilot plant. Next slide, please. Now, this is very, very important. Last week, I went to one of the pilot plants in Abuja here, currently in Abuja. I went to a plant, and why did I get there? The person called me that they are having a lot of, it's a lead and zinc beneficiation plant. But I came to find out that most of the lead and the zinc are present in the tailing. Imagine having a tailing, to those of us that are in chemical and mineral processing. Imagine having Sorry, I call me. Sorry. So imagine having a lead and zinc in tailing up to 20%. So that means that a lot of processes were not controlled during the plant startup. And this is giving them a lot of issues because for them to, fix up this troubleshooting, they have to start again from the beginning. There's a lot of testing that has to be done, and they are going to spend a lot of money because all this testing was not done at the initial, start of the plant. So pilot plant is very important. Before you start up any processing plant, you first of all you must have a pilot plant. A pilot plant is just a prototype of the main plant. The pilot plant is like a specimen of the main plant, but in this case, it's very small. Say, for instance, we are having a ball mill of, let's say, a ball mill of 500 tons. Okay, let's say 50 tons as weight. In your pilot plant, you can just have 1 ton ball mill. So everything in the pilot plant are just smaller, in size. But the main function of the pilot plant is to reproduce whatever the larger plant is going to have at the long run. So everything you're going to process lithium, you start first of all from your pilot plant. Because from the pilot plant, you're able to identify things like hazard. You're going to check if your chemical dosing is going to be okay. You're going to check the concentration. You're going to check the dosage, everything. You streamline everything, all the processes, and also give you opportunity for you to experiment with the inputs and the output, and also process everything will be done on the pilot plant. So once your pilot plant can either pass or fail. If your pilot plant passes, then you can now proceed to the actual, construction of your main plant. You don't construct before doing pilots. your pilot before constructing. It's the result of your pilot plant, is the test result you've gotten from the pilot plant that will help you in the design of your main plant. So like what I just told you, I went there, a lot of things were not there. Like they are, they have lead and zinc, but they don't have activators, they don't have depressant. So how do you now depress zinc in the presence of lead? So it means during flotation, both lead and zinc are competing for each other. So there will not be efficient extraction of the two metals into the solution. So the pilot plant is very important. This will save you a lot of problems. The pilot plant testing, once it's done, it will save you a lot of cost because you're able to know which part to optimize, which part not to optimize. You will know the dosage to use and which dosage not to use. So all our discussion today is going to be focusing on the pilot plant testing because that is where the actual testing actually comes into play. Thank you. The next slide. Next slide. So this is just a example of a pilot plant. You can see this is a pilot plant. This plant is designed for a 1 metric ton concentrate, just 1 metric ton concentrate. Just that's 1,000 kg. It's just designed for it, but you can't use this to to process at a profit. So this is just a prototype of the larger plant. So after you have done all your testing from the crossing section to the ball mill to the flotation and stuff like that, and once all the parameters are passed, you can now picture this and then make it to a larger plant. Please, next slide. All right, so why test works? Okay, why do we have to carry out tests? It's very, very important that we carry out tests both in plant, on the raw materials we are going to use, because it's not just the plant itself, also the raw materials. There's also what we call integrity test. You have to do your integrity test on your equipment, on your instruments and everything. So one of the reasons why we have to test is for us to fix problems. Your output is actually low grade or an high grade, not just for low grade concentrate, also for your feed. If you don't test, how do you know the classification of your feed? How do you know the chemical properties of your feed? How do you know that that particular feed contains the metal of interest that can be separated with high efficiency, and also high impurity concentration, also low recovery rate, high production cost, and improper equipment selection. So once you do your test, you'll be able to fix all these problems, be able to know when to use high impurity concentration, be able to know your low recovery rate, why is it low, and how to troubleshoot it, your high production cost, and also improper equipment selection. So test will be able to give you scientific support for all this I've just mentioned. Next slide. Next slide. So for there are other kinds of tests to conduct, okay? These are just a preliminary test you have to conduct, like the process check. You have to check, there's a process check for existing plant, a plant that is already in existence. It can be your pilot plant or your main plant. So the process check can either, it occurs both in your pilot plant and also in your main plant. So it's just going to check the cause of problems. So you look at monitor the process, you check what are the causes, what are the problems you troubleshoot, and then you find a solution. Also, there's also a simple exploration test for beneficiation, for investment analysis and initial value assessment of investment before buying a mining claim. You cannot buy a mining site without doing an exploration study. And as a Nigerians, we love shortcuts. I've seen a lot of people just because they went to a mining cadastral office, and a mining cadastral office gave you a coordinate. And it just immediately, because you've seen a coordinate and the mining cadastral man told you that there's lithium, you just went ahead and began to pay money. It's very, very wrong. Once you see a site that you want to buy, the first thing you have to do is for you to do exploration, and not just ordinary exploration. Lithium is relatively a new business in Nigeria, and a lot of our geologists, sorry to say that, but a lot of our geologists does not understand the exploration of lithium. So you have to look for people that have the knowledge, that have experience in exploring this, these metals, to bring them into action so that they can do proper exploration for you. The exploration will be able to know the ore reserve, you will be able to know the kind of minerals that are present. So it's very important you do this. So don't just go and see a mining site and then rush to go and buy it. No, please do a detailed exploration, get good geologists that are available, a mining geologist, a geophysicist, or whoever that has the knowledge of lithium exploration. Get them to site and then get your exploration result. So that test is also very important. And also visibility test of ore beneficiation. You cannot just open an ore beneficiation without doing the visibility test. This particular type of beneficiation, framework I'm trying to adopt will it be able to extract my metal into solution so that I can have at least 90% recovery rate? So you also have to do some feasibility tests on it, a detailed geological investigation and analysis to meet the requirements of evaluation and certification and to determine reasonable process and technological indexes. They also have to do systematic process tests to find out the rules and determine the final solution and the best process index before construction of plant. It's also necessary. Also technical research and tests. You have to have a technical research team that are continuously trying to research, look for new methods, look for new mechanisms for them to be able to resolve the existing problem in your lithium processing lines. And also verification test of process flow for all properties comparison, the selection of reagent plants, the determination of adaptability of different ores in mines. So you have to run a test on all these parameters. You have to understand all these parameters to process check your exploration, study your data from your exploration. You have to study them very well and check if it's actually visible or viable for you to engage yourself into such project. Because you cannot be having a mining site that have the ore reserve for maybe a year and you want to go and open a beneficiation plant. You just waste your money. You waste your money, you waste your time, because after 1 year, where are you going to be getting the minerals from? So you have to ensure you have a detailed test done so that you can check the viability of your project. Next. Next. All right, so when do we do this test? Remember, we have not actually come to the parameters yet. We are just trying to have the purchase of ores. Before you can buy any mineral, you have to run tests on it. In this case, it might be a chemical test. So we are going to come to that in details. It might be a chemical test. You have to understand what you are buying. And that is one of the problems we are facing in Nigeria as long as lithium is concerned. You see someone telling you, a supplier telling that it has 7-grade lithium, 7% Li2O. And once you get there, you take the sample, you get to the lab, you discover that it's 3%. And possibly maybe you were not so smart, you already paid the man, and the man just collected money for 7%. So before you make the purchase of your ore, before you buy any of your ore for lithium or whether lepidolite, amblygonite, or spodumene, you have to run a test on it. The test does not just mean a lab test, all right? The test does not just mean there are a lot of different tests you have to. Physical test, like for lepidolite, the one they call Morgan. That is one of the local method of testing lepidolite in the field. Anytime we go to the field, just carry a bottle of water and want to see a suspected lepidolite or Morgan, we just pour water on it and then it changes color. So we just assume that is so. You have to run test on it for the ore you want to purchase. Okay. The same thing goes to your mining site. You need to also have a data of your mining site. All right. So prior to the detailed prospecting of geology to determine whether further investigation is necessary to reduce the risk of geological investment. I've already said this in the other slide. You need to have a geological investigation have to be done on your prospecting site. You don't just need to enter there as if somebody's using the voodoo or juju to owe you. They just give you a site. They want to pay tomorrow. You want to start working next tomorrow. No, it's a process. There has to be a process, step by step. Don't rush it, because the moment you start rushing it, you're definitely going to make mistakes. So please, I don't know if I'm rushing because I'm trying to meet up the time, okay? But I don't know if I'm fluid.
I think it's okay. It's okay. Yeah.
All right. Okay. All right. So also, when do you also need to test? Prior to acquiring your mining license, you also have to test, and that must have been encapsulated during your exploration. All right. Then prior to the construction of your plant, you also have to, to determine the optimum beneficiation process, production cost, as well as other investment. So you also have to carry out some tests, including the test of the cost of your investment has to be factored in. Even you have to also test your risk. Testing your risk. You want to open a beneficiation plant in Nigeria. What are the risks involved? The economic risk involved, the security risk involved. You have to also test those risks and check if it's viable. Currently, my company is setting up a lithium refining plant in Nigeria. And I myself have worked. I started my career in a base metal mineral processing plants for lead and zinc. So, but before you set up those plants, you have to calculate the risk. We calculated the risk. If we set up these plants in so-so state, what are the security challenges? Okay, if we want to set it in the south-south, how soon can we get the lithium ores? Because there's no lithium in the south-south, except for places like River State, which is just relatively new. So how do we get materials from the north down to south? So you have to test all those risks. So there are also parameters you have to test before starting up your plan. And also, when changes in all properties happen, to adjust low recovery rate, you have to test. In case of high cost, you also have to test. In case of reclamation, they get down to your tail, so you also have to do the testing. When choosing the when testing your reagent is also very important. Like you have to test the reagents that you're going to use. If you are using collectors in the beneficiation process, there are reagents they call collectors. They are the one they call floaters. You have to test all these reagents, antidepressant, depressant, any of the reagents you are using. You have to test the quality, run the quality, and check if it has sufficient, parameters to be used during the setup of your, of your processing plant. And also, this has to be done yearly, depending on the troubleshooting you are experiencing. So, what does the test work involve? All right, next slide, please. What does the test work involve here? Determination of ore type. The test work, go back. What does the test work involve? Determination of the ore type. So here we'll be able to know the type of ore you are dealing with. All right, we already know the situation that amblygonite is very difficult for us to extract using beneficiation process. If you are ore chemist or a mineral chemist or a mineral chemical engineer in the mineral sector, you understand this. That is why most people, most Chinese, they don't pay attention to amblygonite because of the phosphate content. The phosphate content poses a lot of challenge in the beneficiation process, so we don't actually buy them because you don't spend a lot of money to extract lithium out of phosphate, so they don't buy them. So once you carry out the dimension of the ore type, you're able to know the kind of ore you have. Like if it's spodumene and lepidolite. Spodumene and lepidolite follow the same beneficiation process but different chemicals. Like take for spodumene, for instance, spodumene, you have to activate it with sodium hydroxide. But for lepidolite, you don't need to activate it with sodium hydroxide because if you look at your analytical report, for lepidolite, there is high concentration of sodium. I don't know if you have studied that before, you have seen that before. For lepidolite, if you look at the analytical report, for lepidolite, there is always high concentration of sodium. So once sodium comes in contact with water, the solution already becomes basic. So there is no need for you to activate the chlorite again with sodium hydroxide. But for spodumene, if you look at your analytical report of your spodumene, maybe if you have done a comprehensive analytical work on your sample, look at the sodium content of spodumene. It's always less than 1%. So that means that you have to dose the slurry with sodium hydroxide for you to activate it. So test work will definitely give you the kind of ore, and once it gives you the kind of ore, it definitely tells you which of the beneficiation method for you to use to recover your ore body. So identify the specific properties of the ore, okay, and figure out the relationship between different minerals in the ore. Analyze the composition and content. Rock identification will be of great significance. All this should be gotten from your test work. Assay of concentrate and tailings are required. Going to do analysis of the concentrate so they can be able to know the recovery rate and the efficiency of the plant. And also the tailing will also tell you the recovery rate of the plant. Just like I told you earlier, I went to a plant, there was much of lead and zinc in the tailing, even up to 20%. That means that the recovery rate there is zero. They are just wasting their reagent, wasting their chemical. So analysis test work definitely give you this information, and also determination of specific gravity of water and minerals in ore and concentrate. Specific gravity when it comes to mineral chemistry is very, very important. I'm going to discuss that as we go down. It's very, very important in surface chemistry. We are going to learn at that very well. So please, next slide. All right. Now we are at the main topics, parameters that are required to develop a complete flowchart to recover high-grade lithium product from hard rock lithium minerals. So we're going to look at some ranges. If I want to discuss on each of them, it might take us up to a month for each of them because there are parameters inside the parameters. But we're just going to have an overview, a knowledge of what we need to know as a chemist, as as an individual, as a civil servant, as people that love metals or people that love mining. So I'm just going to brief us on a general knowledge. So the first parameter we're going to be looking at, comprehensive high definition mineralogy. We'll be looking at extensive grindability testing, looking at mineral separation, which entails gravity, heavy and heavy media separation. We're going to be looking at flotation. We are going to be looking at pyromethodology, hydromethodology, and environmental testing. For the pyromethodology and the hydromethodology, all these ones comes into refining. They are not part of beneficiation. They are all under refining, because at least from pyromethodology, you are now trying to refine your concentrate so they can have high degree of purity. But from number 1 down to number 3, we We are just at number 4, sorry, we are looking at the beneficiation process. Please, let's look at the comprehensive high definition methodology. But even before that, I think there's a next slide, please. All right, this is a flow chart of basic things you just have to understand about lithium beneficiation plants. This same flow chart is also what we are constructing. So basically everything is the same, but here we'll specify the type of mineral we are using. The type of lithium ore we are using here is spodumene. The spodumene is very easy to extract because it has less impurities compared to lepidolite, compared to amblygonite and the other families of lithium. So spodumene is very, very easy to extract because all the other constituents are basically metals. And once you know that once there are metals in your ore body, they can easily be extracted through magnetic separation. So spodumene is always very easy for you to separate. So first of all, you fit your ore body. I'm just going to give you an overview of this so that we can now go back and look at those parameters to test. So just have an overview of this. It's nice so that you understand how lithium is being gotten, the lithium carbonate and the lithium hydroxide, how it's being gotten. So you feed your ore, all right? You feed your ore body maybe from your mineral side, from the mining side, all right? They bring it down to your primary crusher, all right? The primary, when you're bringing it from your mining site, I think the diameter is around 2,000 to 2,500 millimeters in size, okay? From 2,000 to 2,500 millimeters in size, depending on the blasting, the level of blasting that was done to remove the boulders. But the size always within that range from 2,000 to 3,500 millimeters in size. So once you bring the mineral ores, you take them down to your primary crushing. Your primary crushing will further break down the size of the mineral and then send it down to secondary crushing. So all these are embedded what we call jaw crushers. There are two kinds of jaw crushers: the jaw quartz crusher and the jaw fine crusher. Just like the name implies, quartz, it means it crushes it, but it's still quartz. Then fine crusher, it crushes it to somehow a little bit fine, particle. Then it goes to your optical sorting. All right, your optical sorting can be your classifier, where if the particle does not meet the recommended particle for the ball mill, you have to send it back to the primary crushing section for it to be crushed. Then it now moves down to your ball mill. The ball mill does the work of liberation. It liberates all the mineral constituents of the ore, all the elemental constituents of the ore. It liberates them by turning them into powder so that they can easily form solution. So at this point, like our own construction, the particle size, the grain size from the ball mill is around 75 microns. Yeah, 75 microns using 200 mesh size. So it's around 75. So you can see from 2,500 millimeters, you are getting a feed from the ball mill at 75 microns, very small, it's a powder. 75 microns as a powder. So you can see. So there are parameters to study here. So we are going to be looking at those parameters like grindability test is at the ball mill, from the ball mill down to the crusher. So we're going to be looking at that. But let's just have a go down so that we'll go back to those parameters. So once it gets down here, so if there are elements that are magnetic in nature or ores that are magnetic in nature, they get separated at the magnetic separation. I don't know. Are you seeing the flowchart, please? Are we all seeing the flowchart?
Yes, we are seeing the flowchart.
Okay. So if there are some minerals that have some magnetic properties, they get separated at that magnetic separator, where they cling to the surface of the magnet and then they get separated out as a magnetic waste. You can see the arrow going up. And then the ones that are not, lithium is not magnetic. It has very low degree of magnetism. So it definitely will not be attached or will not be attracted to the magnetic separator. So it moves down to the gravity separation. And then I told you about specific gravity. That specific gravity is very important when it comes to mineral chemistry. Now, the specific gravity of lithium, I think, is around 0.5 grams per cm cube. You can confirm that, but I think that is the range. 0.5, 0.7, depending on the impurities. But we're looking at high-grade lithium rather. So it's 0.5 gram per cm cube. So certainly, and we know that the specific gravity of water is 1 gram per cm cube. So if you have two body, one having a specific gravity of 0.5 and the other one is having a specific gravity of 1, definitely the 0.5 is going to float. So that is where gravity concentration has to come into play. And within this gravity concentration, we have what we call dense media separator, and what is this other one called? Hydrocyclones. Yeah, hydrocyclones also comes to play here. Then during the process of concentration, there's going to be mud, the muddy part of the material that must have been formed during the agitation process. So it's being deflamed. It's being removed through this deflaming chamber, and then it moves down to pre-flotation weir dosing. That is like here, also referred here as just chlorite. Weir dosing happens here, where you condition your ore body. All right, the ore body is being conditioned at this stage. You can either add collectors, can add floaters, can add depressants, you can add antidepressants, just to to change the chemistry of the ore body so that they can be floated at the flotation cell. That is what actually happened at this slurry stage. So that moves down to the spodumene flotation itself. So this is where the lithium body is being floated, okay, because of the high buoyancy due to the fine grinding that happens at the ball mill. So because of the high buoyancy, it floats here with other chemicals that are added, like the collectors that are added to make it float, have that characteristics of floating. So it floats here, and then it moves down to where you now have the concentrate. From your concentrate, you have thickening and filtration, where the water will be removed. Once the water is removed, we now move to our concentrate tank, or that is where pyrometallurgy takes place. We now subject the ore body to at sometimes 1,500 degrees centigrade for us to do calculation. We remove every organic matter that is present in the concentrate, so that at the end of the day, you can see the last. Look at the last drawing there that looks like sand, a heap of sand. You can see you're having 99.6% lithium carbonate or lithium hydroxide, depending on the kind of exchangers, the ion exchangers that were used in the process. So remember here, sorry, I forgot to tell you this, the feed oil for this spodumene we designed is 1.5. So it's 1.5% of lithium hydroxide, sorry, lithium oxide. 1.5% lithium oxide was feed. At the end of the day, at the flotation, at the concentrate, we are having 67%. While at the filtration, after pyrometallurgy, we are having 99.8%. So you can see that we are wasting most of our ores in Nigeria, because the Chinese man will tell you that if it's not up to 3%, it's not buying. If it's not up to 5%, it's not buying. But you can see that at the end of the day, from 5%, we're able to concentrate it to 6 to 7%. So we can actually start this beneficiation plant in Nigeria. We can do it individually, we can get funds, we can get loans, we can start it. If you go to all the mining sites now in Nigeria, even our own mining site, we already ship, we have what we call the intercalation ore. Those intercalation are ore that are not up to 3%. We just keep them up because of the refining plant. So once the refining plants come on board, we just take all those materials and then concentrate it to 7%. So you can see that we are just wasting a lot of our minerals because we don't have a beneficiation plant that can concentrate the mineral, that can convert the mineral from 1.5% to 7% for us. So I think this is just a flowchart, a simple flowchart of the spodumene beneficiation plant. So next slide, please, so that we look at the comprehensive high definition mineralogy. Now, this is very important. Test work in mineral analysis is very, very important. For you to understand the constraints of your mineral, you have to test it. Just like I told you, it's not every lithium ore that gives 7% is spodumene. All right? It's not every lithium ore that gives you 8% is spodumene. Some lithium, I think last week we analyzed a lithium sample that gave us 4%. I can shock you that lithium that gave us 4% was amblygonite. But you might not know, because a supplier gave you a sample and the sample is giving you 5%. You're happy, hey, I have spodumene. At the end of the day, you wasted your money, because you are now paying in terms of spodumene, not as amblygonite. As of today, I know that the price of spodumene, because of the market, is around 1 million naira, and that of amblygonite is around 600,000. So you're now going to pay for amblygonite for 1 million naira, and now wasting your fund. And at the end of the day, it does not meet your buyer's specification. So test work is very, very important when lithium is concerned. And in Nigeria, let me tell you the gospel truth, that's the problem we are having, including our so-called government labs. I don't know if there's any government personnel here. Please, you have to go and work on your people. Let's have reputation. The sincere truth is, I've analyzed a lot of results for international companies. Sometimes they will send me a report and say, hey, Chris, analyze this result. Look at this result very well. And most of the results I've been getting from Nigeria, most of them, 90% of them are doctored. I'm telling you the gospel truth. Either doctored, or they do not have the proficiency for them to carry out analysis on, on lithium minerals. So please, you have to be very careful of the lab you send your samples to. The lithium analysis lab should not be done on anyhow lab. It should be done on a lab that knows what they are doing. And there are different instrumentation that can be used to assess your ore body. I've listed a lot of them here. AAS, atomic absorption spectrophotometer. I've also listed ICP. I've also listed XRD. I've also listed the SEM, scan electron microscope, and also XRF. Now, XRF can be used for elemental analysis. You want to see constants like silica, iron, as I've listed on the slide, you can use your XRF to also determine that, to save you cost. Because if you want to use AAS or ICP, you're going to spend more because of the LAM and then because of the cost of the equipment. But your XRF, you can just shoot your sample and then you see the elemental constraint of this mineral. And also, there's also a new device in the market now called LIBS, LIBS, laser induced breakdown spectroscopy. It looks like exactly like XRF, but this can also check lithium content. But to me, as a professional, I don't advise that. It can only be used for pure work, not for the overall assay of your quality. Don't use it for overall quality of assay of the quality. Only use it for field work to check if lithium is present or not, or if that particular site is a pegmatite vein or not. So also loss on emission can also be checked by gravimetry at 105. Sorry, that is not 1020. It's 105 degrees centigrade per hour. These are also parameters we check on the lithium mineral. 105 degrees centigrade, not 102. 105 degrees centigrade per 2 hours. The lithium content can be accessed through air or ICP. And please note this: any method that you're going to use for the analysis of your lithium content, please, that lithium must be flame technique. Must be a flame technique, meaning that the material has to be burnt, the atom has to be atomized, either through absorption or emission. You should have a detector that either can detect through absorption or emission. So it must be a flame technique, meaning the sample itself must be burnt, must be ionized. So the flame techniques we have can either be a flame photometer, it can either be AAS or ICP. All these use this heat to optimize, to atomize the lithium content in the material. So next slide. This is a result. This is a result of a test work that was done for a lithium material. You can see the elemental constraint, and you can see here 2 instrumentation was used. ICP and XRF was used. You can see in this case here, the XRF couldn't detect lithium because XRF does not have the capacity to detect elements of low atomic radius. Somewhere I was in a presentation when someone told me that he used XRF to detect lithium, and that was a very false information. XRF cannot be used for the examination of lithium. The atomic weight or the atomic radius of lithium is very low for fluorescence to atomize to excite it. So this is a typical example. So you can see all the components that is there. And these are actually because lithium itself is either aluminosilicate or aluminum phosphate. So meaning you must have alumina, you must also have iron are also impurities present, sodium, potassium, and the likes of them are also present. So I think this is a typical example of analysis of a spodumene ore. So you can also see all the different elements that are present. So without chemical test, without you testing your ore that you want to feed into your plant, how do you classify this? Now, me, myself, personally looking at this result, I can tell you that this result is from a spodumene. Why? Because look at the sodium content, it's less than 1%. Look at the potassium content, it's less than 1%. Look at the phosphate, it's 0.03. So with this classification from my test result, I can definitely confidently tell you that this is a spodumene. And if it's a spodumene, I have to design my plant, the reagent I'm going to use, I have to design it to suit the flotation of this spodumene material. But if I don't have the chemical work, if I don't have a lab work on it, how will I know? I might not know. And even in this case, 4% to me is a high feed. I can't feed this into my plant because it's already high. What I need is just 1.5 or minimum 2%. Then I can now concentrate it to 5 or to 6 to 7. So chemical analysis is very important that you can be used to understand your ore body. Next slide. And also XRD also give you a phase differentiation. Like the XRF and the AS cannot tell you the type of spodumene, the type of lithium. The XRF, the ICP, OES, and the likes of them, they will not tell you the type. But with XRF, with phase differentiation, it's going to tell you which of the lithium ore is present in the site. Please look at this. The next slide. Look at the next slide. Now, this is a typical result. This is a typical result from an XRD analysis, all right, that was done for a sample that I want to use in my plant. All right. So you can see now that the XRD analysis reveals from the chromatogram you are seeing there, it gives you the different kinds of lithium that is present. You can see alpha spodumene and beta spodumene. The alpha and beta is just difference in temperature. The normal occurrence spodumene is alpha, and then once you heat it to 1000 degrees centigrade, it's converted to beta. So in the processing, in processing, once it gets to concentrate, What we are now working with is beta spodumene, no longer alpha. But at that initial ore stage, raw ore is alpha spodumene. And then you can also show you the quartz content. You can also show you the arbite and the lepidolite, barrier, and other. It shows the compounds that are present other than just the lithium. Or even if it's a lithium material, what kind of lithium is present? XR is going to give you that phase differentiation, that detail. So chemical test is very, very important for for as one of the parameters for working on a lithium processing line. Please, next one. Now, this is also very important. When I was explaining the flowchart for lithium processing, make mention of the ball mill. I make mention of the crushers, the jack crushers, the primary crusher, secondary crusher, and the ball mill. Now, this is where their factors come into play. Extensive grindability test. Now, a grindability test is a procedure that evaluates the resistance of a material to a ball milling. All right. This test is an effective way to calculate and compare the bond work index, BWI, of different ores. The higher the bond index, the more difficult it is to grind the material. Now, you have to understand your ore body. How hard is your ore body? Because the difference, the hardness of the ore body determines the kind of crusher you are using. There are some beneficiation plants like the one they currently, what is it called? They currently inaugurated in Zimbabwe. They currently commissioned in Zimbabwe. I have a friend that is working there. They only have one crusher. They only have secondary crusher. From secondary crusher, it moves down to the ball mill because they were able to do a grindability test to study the hardness of the material. So before you even set up your plants, you have to understand how hard is this my mineral? Is this my mineral hard? And what is the extent of the hardness? So that's what the grindability test is all about. And because if you don't test this, and then you go and use a particular if you don't sorry, call just came in, sorry. If you don't test this, you might end up using a ball mill that does not have the strength to grind your ore body, and that may lead for you to be changing your ball mill almost every month. And one ball mill, like the last one ball mill with that can give us one ball mill should be around 10 million naira. So, and you want to be changing that every month, and so that is not cost effective. So you have to understand the grindability test, the result of your grindability test. So this procedure is important in mineral processing industry as it helps to determine the proper equipment necessary for grinding by estimating the power and the energy needed to achieve desired grinding result. So it's not just about you feeding your ore into the crusher. Does the crusher have the strength to grind the ore? Does the ball mill have the strength to grind the ore? So there are parameters you have to test, and that is done. It's called grindability test, and it's done in the lab too. It's not. It's done in the lab, though it's not done by a chemist. It's done by a chemical engineer. There's a mineral chemical engineer that does that. I've engaged in this kind of test. So it's the chemical engineer that does it. So you have to test the strength of your ball mill. You also have to test the strength of your crusher to be sure that your crusher is able to crush the material efficiently, and also your ball mill is able to grind the material efficiently without getting itself damaged in the process. So grindability test is very, very important. So let's look at, I gave a ball mill here. Next. This is just a ball mill that does the grinding work. Like our own, it converts how many 25 mm is feed. 25 mm is feed into the ball mill, and then at the end of the day, we're having 75 microns, or at 200 mesh size. So if you don't understand the grindability study, you might end up losing your ball mill all the time. So because there are different kinds of ball mill for different specifications, you cannot use the ball mill that is used in gold. Okay, you can't use that one for if you are doing maybe you want to do rotite, tin ore. You can't use it because they have different bond strength. They have different grindability test results. So you have to use a ball mill that has the capacity to be able to grind your ore body into the specified size without getting itself damaged, and at the same time also are going to have efficiency, because I'm also going to have efficiency of grinding. Meaning, this our study does not cover that. This our presentation does not cover efficiency of grinding. But in a nutshell, you are feeding in, let's say you are feeding in 100 kg of material to the ball mill. How many percentage do you have as the output of the ball mill? So you can also calculate the efficiency of the ball mill as well. Please, the next slide. So this is just what happened actually in the ball mill, where there's impact. For material to be grind, there must be impact, all right? Two materials coming together with each other, and then compression. Compression must take place where the balls, that's why they call it ball mill, ball. So there are balls inside that eat themselves together. So they also eat themselves with the material, thereby bringing the material into a tiny particle, which we call it compression. And also there's friction, you know, two surfaces of the material come in contact with each other, there's friction. So that friction can also result to, you know, the grinding nature of the material in question. So if your bond with energy is not enough, impact will not be efficient, compression will not be efficient, and friction too will not be efficient. At the end of the day, you might end up not having the required, grain size for your beneficiation. Remember, beneficiation deals only on grain size. If the grain size is not fine enough, it can't float. It can never float. So you must ensure that your grinding test is positive. If it's not positive, you have to go back, study your ore nature, then look for a ball mill that has the capacity to grind the ore. Please, next slide. So these are different kinds of, ball mill, other types of techniques that are used for grindability test. All right. I think once the slide is being shared, you definitely go and read on it. But just we are emphasizing on bond work index test. That is the one we are concerned about because that is the one we are using. Bond work index test. So this one is to calculate the power requirement and the size, rod, and ball mill for a circuit. So if you can only do this bond work index test for your plant, it's enough. It covers everything because it will determine the power. When we are talking about the power, we're talking about the energy needed by the ball mill. All right. You can't be having a 500 kVA generator and you are using a ball mill of 499. You definitely kill your generator. So, but doing a bond work index definitely calculate the power of the mill, and at the same time, the size of the rock, the size of the balls that are needed to grind your material into the the needed size. So these other ones are different tests. So, but I'm not going to pay attention because of time. So we are just looking at the bond work index test. So next slide. These are other ones. All right. Okay. This example of a ball mill. Please, next slide. FC bond ball mill. This is the equipment that is used in doing grindability tests. So let me just give you the procedure, a quickly run of the procedure. How do you do this grindability test for you to determine if your ore body is suitable for that particular ball mill? Please, next slide. A test sample is staged, all right? So your feed, okay, that is crushed to 3.5 millimeters, all right? Maximum feed size, and then it's compacted into 70 centimeter tube. You just have a tube, either a glass tube or a PVC tube. You add 3.5 millimeters of your feed size into this tube. You compact it very well, make sure it's compacted. Then you measure it. Once properly measured, the sample is placed in the universal FC ball mill. That's equipment that I just showed you before now. You place the sample inside there to accurately calculate the bond work index of the material. What does the machine do generally? The machines carry out what we call revolutions. Once you put your sample into that machine, there's revolution. So as the revolution is going on, remember what I showed in the other slide, impact will be recorded, compression will be recorded, and then friction will be recorded, because these are the three parameters that causes grinding. All right. So these are the three parameters that covers grinding. So these are the three parameters that covers the grinding. So after a set of revolution is completed, the sample is removed and then screened over 100 mesh size. So after the grinding is done, after the revolution is completed, you have to add you have to screen it through 100 mesh size, and then you calculate the amount that is on the top, like you can call it supernatant in this case, the supernatant that is on the top of the screen size, you can call that one negative, and then you calculate over the one that passed through the 100 mesh size. All right, so we are having two things now: the supernatant negative on top of the mesh size, and then the one that passes through the mesh size. You can call that one positive. So those are the two values that we are going to use to conduct, this test. Now there's a formula. Please, next slide. Okay. Now the bond work index. Remember, we're looking at the bond work text. The bond work index measured in kilowatt per hour, typical value ranges from 7 to 20, all right? Some material has BWI of between 7 to 9. Anything over 14 is considered hard. The hardest material can reach. So once you do this test, your result is definitely going to tell you which of the ball mill you are going to use. Remember, there are a lot of chemical engineering work that has to be done here, but I'm not taking us to the chemical part, the engineering part, please. So I'm just trying to make us just have a knowledge of what a grindability test is. There are a lot of calculations here, but we are not touching that. But just what we just want to know is that you have to know if your material is soft, if it's suitable for that particular ball mill. If it's not suitable, then you look for another ball mill. So, for instance, look at this scale. Next slide. This is a table, all right, that shows different minerals, bauxite, copper, down to zinc ore, with different bond work index, all right? So, and we already classified, according to our previous slide, we already classified that from 7 to 20, from 7 to 9, they are soft, all right? They are soft material. But anyone that has a value above 14, they are considered to be hard. So you can look at this table here. We have, look for copper. Copper is 12. So it's relatively still a little bit hard. They look at limestone is 12 too. Look at zinc ore and rutite too. They are also 12. So these ones are also relatively hard. So, but this equation, you can also see equation here. After you have done that test, the grindability test, remember I told you that you're going to have some part that is suspended on the top of the mesh side, and there are some part that are going to be suspended on the bottom of the. So these are the factors, the P. 80% passing size in the micron, the one that passes through, and then 80% passing size in the microns in the feed. So you take all these parameters into the equation, you'll be able to calculate the bond work index. And once you have gotten the bond work index, you're able to look for a ball mill that have the capacity to to mill or to grind that particular ore body. Next slide. All right. So next slide. So mineral separation. All right, for the mineral separation, we have gravity. I also have AV liquid and AV media. So for gravity test, also known as gravity separation test, are used to determine if an ore constituent can be concentrated by exploiting the differences in their density, their shape, or size between the content of interest and the waste material. Remember when I was giving you a flow chart of the spodumene processing plant, I told you about we have a gravity channel, all right? So the gravity test takes into consideration the difference in their density. So if you have spodumene having a density of 0.5 grams per cm3, if you add it to water, it's definitely going to float. So that is also a mineral separation technique that can be used for in determination of in processing of lithium minerals. All right, next slide. Next slide. Okay, so why use gravity concentration? Why do we need the gravity concentration? Now, gravity concentration is often an effective and economic unit operation with low capital operating cost. It does not need much money. You just have to take advantage of their density of the two materials, the one that is floating and the media itself. So the process can also be environmentally favorable as little to no reagents are used in the process. I told you earlier, it's just your water and then your analyte of interest has been floated due to their difference in density. Gravity separation is an industrial method for separating two components, either in suspension or in dry condition from a granular mixture. Remember, for floating to be done, the material have to have a sufficient buoyancy. You have to take note of that. Because I'm saying that the gravity of lithium is 0.5. It does not mean that if you carry a lump of lithium and add to water, it does not mean it will not sink down. It definitely sink down. But the gravity here, we are considering the gravity based on the buoyancy. So at the buoyancy at a fine grain size is 0.5, which means that it has a density that is lower than that of the water. All right, please, next slide. So these are different types of gravity test equipment that we are using. For us, currently, we are using a cyclone. All right, it also does the same work. It just takes into consideration the difference in the density. If this ore is dense than this one, it's going to separate. Now, if paraventure we have iron, if the iron content is high in that particular lithium material, what do you think will happen? It's simple. Iron has a high density than water. So once you have an iron content, the iron content will sink. So in this case, you're now collecting the iron as a tailing. Okay? While you're now collecting your lithium as now be at the fruit, because we'll now be fruiting on top because both of them have different densities. So we are currently using hydrocyclones, all right? There's also dense media separation, arm panning, and so on and so forth. So these are different types of gravity test equipment. Next. So how do we conduct gravity test analysis? How do we do that as a chemical engineer or as a mineral chemist? First of all, gravity test procedure can vary depending on the type of equipment being used. Just as I said, there are different kinds of equipment like the hydrocyclones. So if you are using hydrocyclones, there are different kinds of techniques you have to use. Generally, a known amount of material is processed by gravity concentration equipment. So you send the material to your gravity equipment, all right, with the different reagents, all right. If you are using water or any other reagent you are using, you feed in the material, result you're going to have a concentrate and a tailing product. The concentrate can be the one floating, or it can be the one at the bottom. You collect it as tail, as the case may be. So the concentrate and tailing are then weighed, dried, assayed to determine final constituent mass balance and recovery. What do we mean by this? Remember, the purpose of processing is for us to concentrate the ore. So take for instance, you are feeding in 1.5% Li2O. Now, if you pass it through gravity test, we are expecting you to have at least an increment from initial feed. So if the increment is not, after you've gotten the increment, rather, you have to calculate the percent recovery of the increment. So if the percent recovery of the increment is not sufficient enough, then that means that your gravity test, something is wrong, you have to revisit it and work again. So how do you know that the increment is sufficient? You have to test the concentrate that is gotten from the gravity test and also the tailing. Remember, either the one floating or at the bottom. You have to test those two, and then from there you get the result. Is that result you're going to use to, to fine-tune your process. Okay, next one because of time. Next. Yes, flotation is very important part of mineral processing. And I think this is, I will just, after I've taught flotation, I think we are almost at the end of the slide, so don't worry, we're almost going out now. It's very important, especially when it comes to lithium, all right? There are other different, techniques that can be used for extraction of lithium, but flotation gives us the best recovery. And currently, from our plants, the specification, everything is done based on flotation. And if you have been following what I've been saying initially from the beginning, flotation is just is the most widely used method for the construction of fine-grained minerals. It takes advantage of the different physicochemical surface properties of minerals. You have to do with the surface chemistry. All right. Sometimes surface chemistry might not be an inherent nature of the ore. Please take note of this. Sometimes the surface chemistry of the material might not be an inherent nature of the ore, meaning you have to impact on it by using chemical and reagent. Like for lead and zinc now, all right, if you are processing lead and zinc, once you get to the slurry, you have to add different chemicals. You have to add your MIBC, your xanthate, you have to depress, you have to activate copper sulfate, zinc sulfate, and so on and so forth, because you want to play with your surface chemistry. You want to see which one can float at the expense of the other one, all right? So the property, the surface chemistry property sometimes might not be an inherent nature of the material. Sometimes you have to enforce on it by using some chemical, reagents. And once you use those chemical reagents, you can either alter the hydrophobic nature of the ore, all right, or the hydrophilic conditions of the surfaces of the material. So once you are able to alter this, you'll be able to know which one is going to float, and you're able to know which one is going to, is going to be on your tail. Take for instance, lepidolite. Our plant is set up in such a way that we are going to be doing beneficiation of both lepidolite and spodumene in the same flotation cells. Meaning, at the end of the day, we are going to float both lepidolite and spodumene. All right, because of the chemical constituent, which was reviewed to us by our test analysis. And I told you that lepidolite has more of sodium. All right, and once it has more of sodium in contact with water and other chemistry, you have sodium hydroxide. So the solution becomes automatically basic. So the lithium can be activated. So first of all, what do? You activate your lithium. Either if it's lepidolite does not need activation because the sodium content is enough to activate. Because how do you activate? You activate it using a basic media. The solution must be basic. So we use sodium hydroxide, caustic soda to create this basic environment for this process to take place, for this flotation to take place. For lepidolite, there is no activation. But if the material is cool, we have to activate it with sodium hydroxide. We have dose of sodium hydroxide to activate it. And then for collectors too, okay, we have to make it to float. There are different mechanisms. I'm not going to go towards that. That is chemical engineering, so I don't want to take us out of the scope. But for us to collect it, like collectors that they won't float it. So if it's for lepidolite, you have to add amine collectors. Amine, like there's a amine group, compound that has a amine group, is very hydrophilic, it loves compounds that have those lepidolite characteristics. So if it's lepidolite, you use amine collectors to collect your lepidolite. Then if it's spodumene, you can use fatty acid, okay, or cholesterol as your collector. So it's very important. But this flotation process is not efficient if your grinding process was not optimally, done. If your grinding process was not done properly, if you did not get the appropriate or the right, feed size that is feed into the flotation cell, the materials will not float. Because I told you that for materials to float, it must have a high degree of buoyancy, so that with a little blow of air, maybe the air can come in pneumatically, maybe from the system, or it can be inbuilt in the flotation cell. So with a little blow of air and addition of chemicals, activators, the material, the lithium ore, to be able to float easily without much trouble. So your grindability test is very important for flotation. If it's not done properly, then you're going to have issues with your floating. There are different kinds of tests that can be done in flotation tests. Capacity of the cell test can also be done, where you test the capacity of the cell. If you have two cells, what is the capacity test? You can do a capacity test on the flotation cell. There are a lot of things to be done. So next slide, please. So this is just one of the tests that was done, okay, for flotation test. You can see the fruit, those things coming up, okay, like the bubbles, okay. Those are the minerals of interest. Maybe your lithium that you are beneficiating, they are floating, and then they will be scraping out. There are a lot of processes you're scraping out. You can move down to your scavengers, you can move down to your roughers, your cleaners, and then finally to your concentrate and to your tailing. So those are just a chemical aspect of it. But look at it now. There are foams that are forming. So it is the mineral now that is coming on the surface, because it has a very great high degree of buoyancy. And then because you have been able to maneuver the surface chemistry to make some of them to stay in solution, and also to make some of them to come out in solution, you have been able to play around with the chemistry of this surface material. Then you're having this floater coming out, and then you scrape it out. Whatsoever you're scraping it out contains the analyte of interest, which in this case is our lithium oxide, rather, not hydroxide. Hydroxide is gotten from the refining process. It's oxide that you get from the beneficiation. So all these things you are doing here, you are just trying to get oxide to concentrate it to 5 to 7% oxide. Next slide. Then we are almost done. Now, flotation test, very simple. A known amount of oil and water is added to create a slurry. Okay, we create a slurry. Okay, we'll add a known amount of oil and also a known amount of water. Sorry, is added. We create a slurry. All right, slurry like a paste. Just like what I showed in the previous slide, a slurry like a paste. Then we'll add reagents. All right, why are we adding the reagents? I told you earlier that some of these minerals, okay, does not have an inherent surface materials. Okay, so you have to alter their surface chemistry. So sometimes you add reagents to it. Okay, so in this case, we add some reagents. We add some activators to it, sodium hydroxide, depending if it's spodumene or lepidolite rather. So once you add it, you'll be able to alter the surface chemistry of this material. Then the chemical collectors are added to the slurry to form hydrophobic surfaces on the constants of this interest. All right, so you form hydrophobic surfaces. When we say hydrophobic surfaces, it does not get itself attached to the solution, because hydrophobic does not react just on its own. It does not love anything. So it's easy for this hydrophobic nature to just come out from the solution and then you scrape it out. Now, air or nitrogen is then bubbled through the agitated slurry. All right, the air bubbles come into contact with the hydrophobic surfaces, transporting them to the surface where they form a fruit or foam. The hydrophobic nature, which you have changed using your chemical dosing, all right, is blown up by air or nitrogen, or sometimes like the ones we have here, you are not going to add any blowers, a blower, not adding any a compressor. It comes together in the system. But there are some you have to fabricate a blower that will increase the buoyancy of the grain material. All right, so it blows the material as air bubbles, and they come in contact with the hydrophobic surfaces, transporting them to the surface where they form a fruit or a foam, like what I showed you. Creating a concentrate. The solvents, and then you have your main listing. All right, the concentrate and tailings are then weighed, dry, assayed to determine final concentrate, mass balance, and recover. So after then you weigh you analyze your concentrate and your tailing to check your recovery. If much of the lithium has been in your tailing, then it means your process is not efficient. So you have to go back to your process control or your chemical engineering and check what is wrong. This is all done in a pilot plant. You can't do this in a large plant. That is why you have to control all this process when your plant is still on the pilot stage, so that once you move to your main plant, it's just a matter of just fine-tuning the process, but not you starting all over again from the beginning. Like I told you, the plants I went to earlier, those guys, they have a lot of things to put in place. Just like Mr. Bill said too, that I went to a plant too. If you don't control this process in the beginning, you're going to spend a lot of money and you're going to waste your energy, and who knows if it's going to work or not. So you have to test all these parameters. Okay, so pyromethodology, that one has to do, please next slide. Pyromethodology has to do with, next slide. Okay, has to do with, you treat, now you've gotten your concentrate, all right, you are trying to move the concentrate from just being a concentrate to a refined lithium hydroxide or lithium carbonate that can be used for the production of our ESS, energy storage system. So it's just for you to do calcination, all right? You subject the ore into high temperature, sometimes using a furnace. They use a furnace, or it can be a hydrometallurgy process. So you use a furnace, you heat the temperature, the concentrate, you remove all the organic matter that might be present, and every other volatile organic constraint that is present, you remove them, and then the refining process continues. You pass it through your your ion exchange, you remove any other material that are present through your ion exchange. From your ion exchange, you'll be able to have your lithium concentrate, your lithium hydroxide or your lithium carbonate as either 90% or 99.9% lithium carbonate or lithium hydroxide. And then lastly, which is very important, is your environmental testing, which is what we are still lacking in Nigeria. I've been to a lot of, I've been to 4 plants in Nigeria, one for copper, one for zinc, two for lead and zinc. What I noticed is that our Ministry of Environment are not doing their job properly. Take for instance, you have a sodium cyanide, you can't dispose your sodium cyanide properly, and it gets back to the environment. It has a lot of implications to the health of the people, to the health of the society. You are putting the health of the society at risk. So you have to, at the end of the day, you have to ask yourself, how am I going to control the effluent I'm generating through this process? It's not just good enough for you to have a pilot plant or for you to want to build a big plant without also taking into consideration the environmental impact, the health impact it's going to have on the general populace. So it's also very important that we do environmental testing. And one of the best ones we normally use in environmental testing is just bottle roll test. Very simple test. It's like a leaching test where you take your ore of interest, all right, your ore of interest, maybe lithium, you add some solutions to it, and then you agitate it. There's an instrument that does the agitation. You can, please, next slide, let me show you the instrument. The equipment that does the agitation. Next slide. Okay, the instrument that shows the agitation. So you insert your sample inside with a different reagent that will cause leaching. Agitation is done. Once the agitation is completed, you take out the solvent or the solution, you take out the solution and run a test on it. Now, why are you testing it? You are testing it for parameters that might be dangerous to health or that might be dangerous to environment, including your marine ecosystem as well. So you test for parameters like mercury, lead, and all the rest, because the solvent you are using for this extraction must be able to extract lead, mercury, and every other, other harmful element that might be present in the ore body. So you insert it into your equipment, you agitate it for some hours, and then you bring it out, and then you carry out a lab analysis to determine the constraint, the mineral constraint, or the azimuthal constraint of each of the parameters, and then you assess it. I think this is just all we have for now. We can't go far because of time, just trying to rush it so that we can, but the chip is just simple. We can all have, we can develop this lithium refining plant. We don't need to waste our 1.5%. The 1.5% can be beneficiated, and we have 6%, and we can now sell our 6%. So no need for a Chinese man to be telling you that it must be 5%. You can always tell them to support you. Tell them to support you that it's possible. You can get a lithium refining plant in Nigeria, in anywhere you are. It's possible. There's nothing there. It's the same flow sheet, same flow chart, the same processes as every other base metal beneficiation, and you definitely get your value. So thank you. Ensure that you do your testing properly. It's very important. Ensure that grindability is very important. Your ball mill should be able to grind, give an appropriate size, and then also your flotation should be able to manipulate the surface chemistry, so you can have a good extraction process. So I think thank you. I can be able to continue further, but thank you very much for your time. Thank you. I appreciate it.
Wow. Christopher, yeah, something else. I need to appreciate you for that wonderful submission. You've done a lot of justice to this topic. So much. I think even if we were actually giving out 3 hours for this, we couldn't have actually finished it. But I was struggling to get the ones I could get. We are very fast, and that I think is okay. I thank you for that presentation. Thank you so much. There are a lot of things to ask, a lot of things to contribute, and I know that we're up to, I think, 47 of us here. We got up to 48 or thereabouts. Okay, we'll go straight. Before we go, please, you might need to, first of all, you can submit your email so that at the end of the day, we can forward the presentation slide and even the video to you. You can submit that before we forget. Submit it on the chat. Then secondly, if you have contribution, please kindly raise your hand. We'll unmute you and call you up for your contribution, and also for any question. Just indicate by raising. Just let's have the sign that you want to talk. We can unmute you to do that. But before that, I need us to just look at a few things. First of all, I need to just make some contribution to what you just said. And there is something on the chart we got here. I will also bring it to your attention so that we can look at it. I think that is from someone from Ghana. Make some submission. I will look at it later. Let's see what the person is trying to say here. Then, okay. First of all, I want us to look at, to clarify this. Somebody was talking about the spodumene. I think the spodumene, was talking about the spodumene SG, the specific gravity. For me, I think that the specific gravity of mainly most of the materials we are talking about, we can talk about the ranges of specific gravity, like that of spodumene can be from 3 to 3.1, 3.2, and all that, and can also be lower. All depends on the crystal structure or the amount of impurities that are actually involved in them. That is one. Then, Christopher, you will still talk on something about that. But let's also understand that, this testing, and also you made mention of XRF. This is not today, even in our previous presentations. We've said the reason why the lithium can actually work well, be detected very well using XRF. I've seen this going on, and I've seen some results people bring to me, and you see that they've used XRF to put some kind of numbers and all that. It's not actually the best to use XRF to test lithium because of its atomic numbers, which is actually less than just about 3. So most of the time, it doesn't actually produce some X-ray signals when using the XRF method. Also, I want us to also look at the REEs, the rare earth elements. Most of them we're talking about lithium, and all that, but we understand that it cannot actually go all together, because it's not just only lithium. This can also go together. The REEs. We also I want you to note these questions. We also want to know the efficiency of XRF when it comes to the rare elements. Do you understand? Because the RE is also found in the pegmatite. So the pegmatite for the lithium are actually the LCT pegmatites mainly. But we also find out that sometimes they also occur together and order. Is there any way we can actually kill different birds with a stone? Testing for lithium, we can also test for RE, because once most of these ores are actually being given out, you find out that most of the ores are 90-something% of the ores in Nigeria are not actually processed or smelt here. You understand? We don't even know the constant or the recompositions of most of these pegmatites and all that. So is there a way, or what the best method of trying to achieve this, understanding the composition of the REEs in some of these pegmatites and also the LCT pegmatite? So keep that. Then also I want you to also say something on the why do we actually want to expand, try to feed in 4-point-something%. What is your thought on feeding in 4 to 5% of lithium ore? What is your take on that? Do you think it's something we can actually beneficiate, or bringing in some other ore that of maybe 0.5, 1.5, and 2.5? Because I've found out that there's a strategy that the foreigners actually use. Sometimes they will tell you they reject something 1.5 to 2% and all that. And if you look at it, the real things are within 1.5 and 2%. And if you go outside the country, they are beneficiating anything 0.5. They make use of it. 0.5, 1.5 is even a good deal for them. Nigeria, they will tell you that 2% is rubbish for them and all that. Yes, if it's because of the export duties and export TPs and all that, why can't it actually be processed here? So if there's a campaign for most of the things to be processed here, I think there will be a lot of market for us when it comes to some of the low-grade materials we have here. Okay, then another thing I want you to also answer is, I want you to make a recommendation on the XRF when it comes to, the particular kind of XRF in terms of quality and affordability, that one can, because it's portable kind of equipment that one can actually use for a quick test. So if you can also make a recommendation on XRF in particular, I will, for most of our participants here, that will be very much appreciated. I think for now, let me stop there so you can do justice to some of these questions before we give some of our participants that actually want to contribute to this. So thank you.
All right, thank you, Mr. Gideon. Your questions, you already answered some part of the questions. So I'll just like the rare earth, for the rare earth metals that are also present, as we are aware, that is also part of the pegmatite. Okay. But most of the laboratory does not do analysis of them in Nigeria, possibly maybe due to limitations of their analytical equipment or also cost of analysis. Because if it tells you that you want to also check rare earth in your sample and maybe they give you a particular charge, maybe you refuse to pay or you might not have the funds to pay. So that is why even myself personally in our lab, we don't run rare earth in lithium as the case may be, but they are also present. They are present too. But notably, I think I've seen uranium, thorium, notably in most of the samples. Those are the two major ones I've seen, thorium and uranium is most of the ones I've seen. Okay, but we have not actually done analysis on it to actually confirm other rare earth elements that are present. Therefore, the XRF to be used for lithium assay, I'm still of the opinion that using XRF to assess your ore quality is a very wrong practice. XRF generally was designed for field work, for geology field work, where you take the instrument to and then you begin to study your ore body, begin to study what is present. Not what you are studying there. You can't use a result from XRF, is not absolute. You can't use the result that you have. Maybe you just use the XRF, you shoot at a sample and it's giving you, let me say 15.8% iron. That result is not absolute. It's not, because XRF only interacts with the surface material, it's surface chemistry. So what about the other constant of the mineral that is inside, the crystallography of the mineral? How do you now determine what is the concentration? Because it's just a rock you're pointing to, and possibly the rock is just a lump. You did not grind it. That is why it's always advisable that during XRF analysis, the party should be grinded, should have a particle size of either 25 microns or 45 microns as optimal. So to me, for mineral analysis, basically, I want to advise you to adopt the result of XRF as an accurate. Now look at it. I use XRF in my first company, lead and zinc beneficiation plant. Why do we use it? We use it for the concentrate and the tailing, okay, and the feed. Now we're able to use it because we really have a standard from the national NIST for both the feed, for both the concentrate, and then for both the tailing. So we're able to calibrate the XRF to give us almost a close range result with that of the standard. But even with that, we still fall back to wet analysis because it always disappoints us because it's surface chemistry. All right. So most of the ore body might not have a sufficient interaction with when you shoot it with the extra with the fluorescence energy. So XRF to me, it should just be an idea, like a pathfinder. It doesn't want to use it as a pathfinder in your geological knowledge. But there's another instrument now they call the LIBS, okay, laser induced breakdown spectroscopy. It's good. That one can detect lithium, but even with that, it should not be used for your quality grading. You can just use it for your geological work. I repeat again, LIBS. You can just check it online later. Laser induced breakdown spectroscopy. LIBS. The cost of it is around 12 million. The cost of it is around 28 million naira as of yesterday, because I just bought that for somebody. 28 million naira. LIBS. Okay. LIBS. All right. So LIBS. So you can use that to detect lithium. And also, you can also, for your field work, there are also portable XRD, also X-ray diffraction, all right, that you can also take to the field also, all right, there are also field one. Initially, they were not field, they were just the ones they would stand in the lab, but now they are portable field one. You can also take it to the field for you to be able to, you know, detect your lithium, this thing. But as it stands, both LIBS and XRF never use it for quality assessment. You can only use it as a pathfinder. But for XRD is good. If you have the one that you can use to the field, XRD is perfect. Once you calibrate it very well, definitely give the absolute result of your constituent. And then for feeding high grade, why do we want to do beneficiation? The purpose of beneficiation is simple. We are trying to concentrate the ore. We are trying to increase the value of the ore, you know, the value of the lithium oxide that is present. So you concentrating, like I went to a plant recently. The plant I went to, they were feeding 20% of lead. They were feeding 20% of lead as a feed. I was shocked because why are you feeding 20% of lead? Is already a high grade. Why waste? You're already wasting. You're wasting the mineral. At the end of the day, they were still having like 15% of the lead in the tailing, meaning there was no. In fact, there was no extraction at all. So when you have the high grade of 4 to 5, look for low grade. You mix it. Even in Royal, so when I was with First Market Limited, when we have our total metal content TMC was 5%. That is the total metal content for lead and zinc for us to use for beneficiation for lead and zinc was 5%. Anything we have more than that 5%, we blend to add. We look for just look for sand around those boulders, like those shafts that is being removed. Just blend those shafts and add it to reduce, so that because we want to concentrate, we want to get more. So feeding high grade does not make any sense. 4 to 5% to us in lithium is high grade. So it doesn't make any sense. So if you get 4 to 5, you can blend it down with your low grade. You can blend it to add your low grade to it, and then you process it and beneficiate it, which will be able to get 6 to 7% out of it, and then you can now do your refining process to get the pure part of it. So I think that is my humble summation on that. So thank you.
Okay, Chris, thank you very much. And there's another thing I forgot I need you to look at. You made a mention of amblygonite, which we know that is one of the highest sources of, when it compares to others, spodumene, the lepidolite and all that. Amblygonite is like highly sought or something. And recently it was actually gotten somewhere from, mainly from Kogi State. Now, you made mention of sulfur. I need you to clarify, make some clarification on that. Why do you think that that is not actually sought for by most of the foreign buyers?
Sulfur? Amblygonite is phosphate, lithium phosphate. Yes. Okay, but you
mention of amblygonite and the content of phosphate and some chemistry content. Why it's not actually sought for? I want you to make some more clarification on that.
Okay. Most of the people that are buying amblygonite currently, they are using it for blending, for fertilizer blending. You know, I also have experience in urea. I've worked with Dangote fertilizer. So I'm also in the oil and gas field also. So most of the people that are currently buying amblygonite, the amblygonite is considered as a phosphate mineral. Despite the fact that we have high lithium content, sometimes even close to 12. From some lab analysis, we have 12% lithium content. It can be used because that phosphate, according to the methodology or from the chemical design, they said it poisoned the catalyst during the refining process. It poisoned the catalysts that are being used during the refining process. So because of that, people don't buy amblygonite. That's just the gist about it. But there are already an advent of a processing plant currently that they're already trying to see how they can efficiently extract the phosphate, before getting to what is it called, the refining stage, so that they can extract the phosphate. But currently, the phosphate cannot be extracted because you're having phosphate as high as 30 to 40%, even some 48% of phosphate. So it's not as if it's 1%, it's fine. So that's why some of our smart Nigerians, what they do is that they blend the lithium phosphate with spodumene, all right, so that they can reduce the phosphate content. But if the phosphate content is 5%, it's fine. But some suppliers give specification of less than 1%. But 5% is not a problem. But when you're getting something like 30, you are feeding 30% of phosphate to a plant. It damages a lot of things.
Okay, thank you. Thank you very much. Also, I'm very much interested in economical part of the whole thing, because we've been in the field, we understand what it takes to test some of these materials. And most of the problems we have is actually testing them, the economics of it, trying to send material outside, trying to do this and all that. I'm interested in a quick analysis, in a quick way of getting an idea of some material before probably trying to send it in such a way that you may spend so much money. You understand? So, and I know that most of our participants here who are actually in the field need something that could help them identify certain things quickly and all that. I want you to share your experience when it comes to the REEs with XRF. REEs with XRF. What is the experience like? Do you think, okay, for example, let me just give you a clue of what I mean. For example, I know that I don't go to the field with XRF to determine LCT pegmatites and all that. But I also understand that in terms of accessories and associations, there are some elements I actually look out for. You understand? I look out for some chromium, I look out for monothene, I look out for some basic oxides and all that, which I know that XRF can do. You get what I'm saying? And that can actually also help me to isolate some materials. And at the end of the day, for example, if I've gathered about 40 and I use XRF on those 40, sometimes I can isolate only 10 that I could go, that actually go for AAX or ICPs and all that. Now, what is your experience with respect to REEs and XRF?
Okay, so using XRF for RE for rare earth element, right?
Yes.
Yes, it will definitely give you there are different kinds of XRF, different make depending on the electron volt, the EV. I think that's what we call it, depending on the energy of the electron volt that is being emitted by the XRF equipment itself. So there are good ones in the market that can actually detect rare earth element for you. But just get this truth from me. Those values you are getting there are not absolute values. All right? They are not. Except you have rare earth elements, CRMs, reference materials that you can use to calibrate that particular matrix. All right? So take, for instance, you are checking for uranium. If you want to actually get an absolute content of uranium in that ore, then you have to get a uranium CRM. Because when you shoot, XRF is made in such a way that while shooting, all right, it can't calibrate all the metals with one shooting. You can only calibrate 1 metal, 3 metals at a time. I think that is for all the XRF I've seen. You can only calibrate 3 metals at a time. So meaning when you shoot, the response of the equipment is only calibrated based on the 3 metals you calibrated for. So every other ones you are seeing, they are just a pathfinders. So unless you have a CRM for that particular, particular REE you are looking for, it's fine. But if it doesn't, don't use it as your absolute value. Just use that a pathfinder, yeah, that RE is present, but I might not know the actual content of the RE that is present. That is my own submission.
Okay, thank you. Let's quickly go to our chat box and let me just read out some of the things we have here. There is a comment here by someone, Hamdia Oliens, actually joining us from Ghana. I don't know if he's here. He can indicate his end, but I will actually want him to actually speak if he's able to do that. But let me just try to, I've been trying to read out what he sent. I can't actually get the true whole thing, but he said, okay, I asked because I disagree with the information is on the part he's sharing. He said, how technical part, after not true, I can't get that maybe some typo error or some things are actually missing. But he said that SG of spodumene is 3 and thought it will sink, not float. You understand? He now said gradability is got assessing the time for 80% passing through 106 microns of all sides. This I didn't get. I don't understand this. And also he said that an XRF on lithium. XRF, he said you can't do XRF on lithium since from the periodic table it is below mg. You understand? That is, I think you said something like that. Definitely, there's no argument about that. But I'm trying to see the part he's actually disagreeing with to get it clear. If he's here, I want him to indicate his hand so that possibly we can give him opportunity to clarify some of his questions. But Christopher, if you actually understand any of the things here, I said maybe.
Yes, for the specific gravity, just as I made mention in the presentation, maybe didn't listen very well. I said depending on the impurities. You know, sometimes the lithium exists with the aluminum silicate. So sometimes this silicate content might be higher than lithium. Iron might also be present. Tin might also be present, and the likes of them. So I'm just giving you a typical example of the specific gravity of the lithium. But once you get to the flotation cell, remember you're already grinding this to powder, all right? So it's already in a pore size. So once it's already in a grain that small size, we are looking at the specific gravity of the actual lithium itself, which is at 0.5. It's 0.5. But the lithium oil itself does not have specific gravity of 0.5. Please take note. It's during once the grindability is being done and the material has the buoyancy to float. Then we'll now look at the two specific gravity of both water and then the oil itself that is floating. And then, mind you, I told you something about gravity term. All right. So depending, it does not always mean that the lithium will float. Depending on the other constituents, depending on other impurities, the lithium body that is being grinded can be heavier than the water, and then it might sink down. So it just depends on the chemistry, and you can also do the chemistry. You can also do surface chemistry or directional bias. You can alter it. There are some chemicals you can alter to make the material, the lithium material, to sink. There are also chemicals that can alter to make the material to float. So we are not saying it's not specific that it must sink, and it's not specific that it must float. It just depends on the chemical alteration. You can alter with chemicals to get that.
Yeah, I understand. That is very true, because that's why we have some what we call negative and positive flotation. You can actually want your material to actually sink, then you collect your gangues. Your gangues will actually float. You understand? And what you are looking for can sink in your cells, or you can make them float. The gangue can actually sink. It all depends on actually what you want to do, or the method is actually available. Thanks for that. And he went further to say that you can actually use XRA. That is the best to use and all that. There's another contribution here. Another contribution here by someone again. I think it is the same person from Ghana. He said, hello, I am Oliengs, a lecturer from University of Mines and Technology, Ghana. I am currently working on lithium and found in Ghana with some Australians. Lithium found in Ghana with Australians. He said, we have done characterization and now to concentrate to about 80% before processing. We don't want to export the raw concentrate spodumene, and I think Nigeria can take a look into that too. I think that's actually what our ministry is actually working on. So thanks for that contribution and that consign from that participant from Ghana. And let's look at our chat now from Nigeria. I don't think, okay, the box is open for any of you that want to. I'm not seeing any hand up for any contribution or for any question, if I'm correct. Is there anybody that wants to do that? Okay, I'm seeing some hand now. Who is that? Yeah, let me see. Okay, okay, I'm seeing Dr. Only one. Dr. Mrs. Salau, okay, I will unmute you to make your contribution.
Yeah. Thank you very much, Dr. Abadia from Ghana. All we are saying is that Africa is now ready to do beneficiation and value addition in all its work of mineral processing along the mineral value chain. As such, we need collaboration, and that is what we're doing now. We're bringing this one on board just for us to have synergy between every country that is going into value addition for this energy mineral we're talking about, which has to do with the green minerals as well as the rare earth element. Nobody have the monopoly of this knowledge for now. We are all learning. So, and when we can do that, to come on board together, look at what we have on our own side in Nigeria, with the present one that is going on in Ghana and other parts of African countries, we reduce the cost or mistake of which some other countries have done. And then we now bring out the best in our own value addition. Who told you that whatever the international community have done could be the best? We can bring out the best of the best if we do it together in Africa. Then it will not be African content. And that is why we're now encouraging the youth to take the battle up, do this thing diligently, so that it can be transparent enough. Every time we talk about cost. Would there be, if there is no fund in this world, we will not live, we will still live. When we do it bit by bit, we collaborate, we synergize with whatever we're doing, we will get there. So, my dear lecturer, we don't want to limit everything to the lecture room now. We want it outside, practical, so that the young one can take from it. This practical orientation is what we need now, and we have to do it diligently. Thank you. Nigeria is one of these countries. Hello?
Okay, you are still talking? Okay.
Yes, sir.
Okay.
Nigeria, that is what the outgoing minister had just done in recent time, that we need to do value addition and beneficiation in Nigeria for all our mineral resources. No one is going out just from mines to market anymore. No, there must be value addition in order to do what? In order to create job as well as well spread and knowledge acquisition. If you don't do it right yourself, you won't know the quality of what you are having at hand. Value addition is the key. When you add to it, there will be very many job creation along the mineral value chain. And that is paramount for any government now in Africa, not just in Nigeria, so that we will be able to get to where we are going, which is the advanced technology. Do the mining rights. When the first presenter was presenting, he said that every mineral or material we find along our exploration or exploitation should be what? Should be kept well. That is the truth. We have to do this mining rights such that we'll be able to do our value addition effectively at lower cost. Thank you.
Okay, thank you, Ma, for that wonderful contribution. We'll have another contribution here by Chukwumerije. He says, practical terms and conditions for collaboration will be fine. Many of us hold different parts of the knowledge. We need to come together. Yeah, that is actually true, because in this industry, everywhere in the world, there are a lot of value chain, there are a lot of stages and processes that are from exploration down to the processing, down to production and all that. We found out that there are different people at every stage of it. So we need it's a thing of collaboration. It's a thing of collaboration. That's why this platform is there for us. You are free to contribute. You are free to share whatever you want to share. You are free to let us know if you have a new discovery. You are free to share anything at all. So that's why we are looking at this as a pointer for most of us in the industry, bridging a gap. Some people that are actually upcoming can actually queue in with this opportunity to actually learn a lot and also meet a lot of people that are also in industry. I meet some of our professors and lecturers also in school to share knowledge and all that. We cannot do it alone. It's a thing of collaboration. So I thank you, Mary, for that contribution. And also, I think you have some, let me check if we have other contribution here or any other question. I'm not seeing any other hands up. And I think we've actually done almost close to 2 hours. That is the case we usually do every month. So I thank every one of us. And I need to acknowledge some special people. A lot of all of us are actually special, but there are people that I never knew they will be here. I thank all of you. I can see Engineer Benjamin, right? So I can see you, I can't see your face. Chukwumerije, thank you for actually participating. The great man David is here. Atonwa Amadi is here, but he has not said anything today, and I've not seen his face. I hope all is well. Mitchell is around here. Mitchell, I thank all of you. And who again? I'm seeing the Engineer S. Lukman is here today. He's not on the mountain. Please, if I'm calling you, I need to be seeing your faces to know you are here with us. Dabs Abimbola, Dabs, thanks for actually participating. You have a lot of knowledge on this. I need you to actually contribute. You've not said anything. Who again? Okay, I can see Yo is here. Sir, you are welcome. You are welcome. Who else is here? Oluwakemi Blessing Jimo. A woman with unlimited knowledge. She's also here. She has not said anything. Who else am I seeing here? A lot of us are here. A lot of people have actually gone out. We are about close to 50 before. We lost about 15%. I think that is okay. We'll make the video available. Please, I want us to turn our videos on so that David, do you want to say something? This one you are smiling. I know you have a lot of knowledge on this lithium issue, but you are hiding. You don't want to share your knowledge with us. This time around, I'm going to give you one topic. You're going to share all the locations where all those lithiums are actually hiding so that we can actually grab from that. Okay, I will, please let me unmute anyone, all of us. Let's see, you can actually say something without being restricted.
We have Professor Kulola here, sir. Professor Kulola is here.
Okay, I can't see his name. I think I saw him before.
Yeah, he asked a question too.
He asked a question.
There are so many questions on the platform, sir.
Adanya is here too.
Okay, he's the one I'm seeing. Where are the questions? Okay, what is the simple way? I'm seeing this one now. Okay, let me see. Maybe it's my network. Okay, I'm seeing what is the simple way. This is by influence. So what is the simple way chemically to test confirm if pegmatite is of lithium bearing mineral for students carrying out a reconnaissance survey geophysically? Now, I don't know, you're asking two things. Influence, you're asking two questions at a time. You are asking simple way to test pegmatite chemically. You are asking another way to test pegmatite geophysically. You understand? Christopher, are you hearing me?
Yes, I'm here.
He's asking, I think you've actually dealt with that, but you can actually throw more light chemically. He's asking geophysically. Maybe I can throw more light on geophysically. You understand? Because I know that it's not your own area. But if you have something to tell him, you can say here. He said for students carrying out a reconnaissance survey in the field, how can he test lithium chemically? Something like that.
All right. It's very simple. Just first of all, just have to ensure that you do your sampling very well, because that's also one of the challenges you are facing in the industry. The lithium ores are not uniformly distributed in the ore body. So sometimes you may just pick one stone and you think that the lithium content is everywhere in the stone. It might not be like that. So if you are going for your reconnaissance survey, ensure that you take adequate and sufficient samples with knowledge, not just doing and picking. Have a good sampling plan, because your result of analysis will be depending on your sampling procedure. To ensure that you do the right sampling, not just to pick a graph of the sample, ensure that you do a random sampling, get your graph and your composite sample, and then you can send it to the lab for chemical analysis. The chemical analysis can be done, just as I said, it should be a flame process, meaning either AS, atomic absorption spectrophotometer, it can be ICP-OES or ICP-AES, or it can be it can even use ordinary flame photometer, can be used for your chemical analysis of the core. But everything depends on your sampling. Don't just go to the field because you are going for recognized sampling. You just see one single stone, you just grab it. It should be a random sample so they can have an idea of what the mineralization is happening about the locality.
Okay, thank you. I think that's okay, that's fine. Geophysically, I think influence, what you need to know that, like I've always said, I said there is no direct, you can't say you are measuring, you want to use any ground geophysics to measure directly anything pertaining to lithium because of the nature of what you're actually looking for. But apart from that, you can also use some indirect, you can detect some associated minerals. You understand? Associated minerals with some of the pegmatite. You can actually use that. And also in terms of structural analysis, you can also use your geophysics for that. Now, there's a work that was actually done in Canada. I said that in my last presentation, I think January presentation. It was a gravity method. So, because it was found that there's a gravity anomaly within the areas where the spodumene are actually concentrated, that can actually be used. And also, if you have most of the time, they don't even have high content of iron and all that. So you might not actually use that. But in terms of radiometrics, you can use some ratios of potassium, ratios of uranium, and ratios of thorium to actually look at some surface lithology. There's always a different signature when it comes to detecting the potassium contents. They are usually very high in terms of potassium to thorium ratio, because thorium is usually immobile. So most of the time, they can give you an interesting clue when you are looking for some of these structures that actually contain that. Then that is that. And I will also look at, okay, there are some other questions here. He said, is there, by Paul Joel, he said, is there any platform I can learn more of this online? Because I am too exposed. I am not too exposed. I'm just a fresh graduate. There are a lot of platforms. This is one of the platforms. This is just one of the platforms that can bring certain things real to you, the way they are in the field and all that. You see collaboration of a lot of professionals here, people that have seen different experiences and all that. So constantly you can do that, and you can, having in touch with the platform and the website and all that, you can be exposed to a lot of other platforms and our YouTube videos. There are a lot of YouTube videos actually posted online that has to do with the exploration, mining, and environment. Okay, another one is, you said Professor Kulola asked question. Please, I can't find that question here. Mitchell, do you have the question? Okay. Please, okay, Chukwumeri, you want to say something? Can you speak?
Yeah, I have something to say.
Okay.
See, in the, like I said earlier time, on the issue of collaboration, I must say that IMSF has done very well. I remember the time I had some samples to test. I spoke with Gideon, and he gave me a contact, and it came out very well. I want to say that we need collaboration. Collaboration in the sense that some of us have access to entrepreneurs who are willing to fund. But the expert knowledge, we don't really have it. I am a geologist. I trained in petroleum geology, classical, and I lecture and I practice. But the solid mineral is coming in handy, and engaging with it, it's easier than engaging with petroleum or hydrocarbon. So I will plead with us that IMSF should move faster into the entrepreneurial aspect of solid mineral, lithium especially, because the craze is moving fast and we are actually losing a lot to these Chinese and the industries. Last week, I was in Lagos and I spoke with some funders who are willing to engage. So IMSF should please come up with practical terms and conditions for engagement in entrepreneurial aspect of solid mineral, because these people will finally, they cannot find people in the local content. You see them moving out to China, moving out to US, and they'll bring those people into this place and they'll capitalize on the loopholes in our solid mineral policy and then rip us off. And professionals like geologists, geochemists, chemical engineers keep floating, saying there is no job. But if all the value chain can be optimized, you will see that there is so much job. So much job. Yeah, Mr. Gideon is trying. You're trying so much. And the last thing I want to say is that we should move in to do institutional partnership for IMSF, the way NMGS is doing it, NAPE is doing it, going to schools to have student chapter. If IMSF can go in to have student chapter, I don't know what law or what policy they can harness to do that. They will engage these students, catch them young, and mainstream them into what we're talking about early. Thank you very much.
That is a great contribution from you. Thank you very much. We've actually started that. Is on the pipeline and very soon. Mary, I think I'll also at the end of the day later on we'll have to speak one-on-one. A lot of things we need to do together. I believe in collaboration.
All right, sir.
I believe in collaboration. A lot of us here has a lot of things to actually do. Please, before I forget, I think we can also submit our phone numbers, because I want to form a WhatsApp group for most of us that are actually participating, so that most of the time, passing information will be only on one platform. I will just do that, so that most of us are actually participating on, on monthly basis and all that, so we can have a way of reaching us easily, even through our mails. Apart from our mails, we usually send mails, but most of the time, I found out that phone is handy to access information before mails and all that. So we can submit our individual phone numbers along the line, so we can also keep a record of them. Oluwakemi Blessing, please, you have 10 seconds. You can speak.
Good evening, good afternoon all. Can you hear me?
Yeah, we can hear you.
Yes.
So my answer goes to Mr. Kiyom Intwet. I think what will help you on the field for recognizance survey is to get UV light. UV light, you want 365 nanometer, UV light 365 nm, not UV light 395. UV light 365 nm is to help your recognizance survey, or not just lithium, but for other elements. When you light up the rock or the outcrop, it's to reflect. The minerals are going to reflect back light. So that will help your recognizance survey. You might not have the opportunity to know thorium, not thorium, pavioclase, not pavioclase, a lot of it at the scratch, but the reflection of light back to you tells you, oh, there's a mineral here, then you can start making research, breaking out of that particular portion of the question. Thank you.
Okay, great contribution there. As you can see, that's why I said that this is a portfolio of knowledge. You see, this is a very straightforward way for a student to actually, and very cheap, you can actually have access to that, and you can do your reconnaissance survey. And Nasia J.O., please, can you make your contribution in 20 seconds? Okay, we are listening.
Okay, yeah, sorry. It is not just a contribution, but first of all, I want to thank you so much for bringing me into this platform. I have never been into, I've never been into solid mineral space before. Okay, but my trip outside the country for an investment summit, I met with some couple of individuals, okay, from who showed interest in some minerals in Nigeria. Okay, and I mean, I came back and I started doing one or two research to see who and who to collaborate with, and this forum actually had given me much more information, coupled with the research that I've made in the last couple of days, to really understand what's happening in this space. And I want to believe that it's going to continue, and I want to be part of it. Given the fact that this person's, they've been, because I just thought it's just going to be something that you just go in and then you do whatever you need to do. But coming here, I discovered that it's much more than that, especially to some questions that individual will ask. Some will ask me for my company details and all of that. And these guys keep calling me every other day. And I don't really know what to say because I'm also being careful, also hearing what is happening here in Nigeria. Because I don't want to be messed up. I really don't want to be messed up. So I really appreciate this, and I will continue, and at the same time gain more knowledge and to see how to collaborate and work with you guys and be able to fulfill the requests and the desires of those I will call my clients, or those who have really shown interest in me that I met outside the shores of the country. Thank you.
That's great. That's great. Thank you. Thank you for that comment. I appreciate that, for that wonderful words of encouragement. Thank you. You can also drop your contact and everything. I think it's very important. We've got your back. Whatever is the issue, we have a lot of people here. Whether exploration, whether mining, whether processing and everything. We have everybody here to actually help you achieve your dreams. Thank you very much. Dr. Mrs. Salau, you want to speak? I'm seeing your hands up, even when I've lowered it down. Oh, yeah. Okay. We have 2 minutes more. 2 minutes more to close. Yes.
Sustain peace and harmony.
Okay. Okay.
Between 20.
Can you hear me?
2006.
Okay. If you can't hear me, I don't have. I'm sorry. I'll have to proceed. Okay, I think that is actually where we're going to draw the curtain of today's edition on this. Please.
We appreciate the presence of Mala Ibrahim Biu, and then the president of an African Geological Society.
We've done that.
We've taken their time to be with us. They are the prominent people. We should not forget that they have the interest of youth at heart, and they are always with you. We appreciate you. That is profs, everybody, and doctors that are here.
Okay, I'm seeing sir now. It's his face I'm seeing now. You're welcome, sir. You're welcome. It's a pleasure to have you on the platform, sir. We can't hear you. We can't hear you. You have to unmute yourself.
Yes. Thank you very much. Watching carefully and listening.
Okay.
And I believe that my own suggestion will be this body should bite more in time of assisting the new administration to formulate policies that will encourage and improve mining. A situation whereby most of our valuable minerals are being exploited by Chinese illegally, and nobody really cares. I think with the group of professionals and the platform, we can come up with a policy in order to approach this government to try and stop this illegal mining by Chinese and to encourage indigenous professionals to go into mining. It doesn't matter. It could be a source of creating jobs in this country. It's one of the easiest. Mining and agriculture should be one of the easiest ways this coming administration should be able to address unemployment. But it's just a matter of priorities. And I believe this body full of professionals should be able to collaborate, come together, and make a position paper in order to stop illegal mining and encourage indigenous miners through government support and new friendly policy. Thank you very much for having me.
Thank you very much, sir. Thank you very much, sir, for that wonderful contribution. Thank you, sir. Ma'am, is there anything you want to say? If not, we need to draw.
He was the national treasurer of the Conference of Speakers of State of Nigeria.
Okay, thank you very much for that. We will appreciating everybody for your time for today's presentation. We hope to be here again. Usually we We do this every last Monday of every month. So next month, last Monday, we're also going to be here with another interesting topic. So we'll be looking forward to some of this contribution made today, how we can come up with some solutions to that. I heard something that he just said, position paper on a way to encourage the new administration to make sure that illegal mining are actually discouraged in our country. And also another interesting contribution by Chukwumerije, that some of the practical terms we need to come up with in terms of how we can collaborate with different bodies or different persons, also with some institutional bodies, so that we can actually catch the young geologists at their early stages. And some other questions, we want to appreciate everyone for all that. We'll say thank you and have a very wonderful day ahead of you, and happy Inauguration Day once again.
Bye.
Okay, bye.
Thank you. Bye.
Yeah.
Of the Living Faith Church, also known as Winners Chapel, and blessed with.
Hey, thank you. People have contributed.